moderator for this panel. Sourav Dey is a partner at DataHoliks, an AI product development studio here in San Francisco. He previously led teams to build products across technology stack, including smart thermostats, power grid forecasting, wireless communication chips, and experimental holographic displays. He spent the greater part of a decade at MIT, receiving an SB and PhD in EECS. Sourav Dey.
Thank you, Sabrina. This is the marketplace on AI, not the marketplace, the panel on AI and marketplaces. I'd like to introduce everybody on the panel. I'll start over on the left. This is Jeremy Stanley, VP Science at Data at Instacart. He's leading all the company's data science efforts. He was previously the chief data scientist at Sailthrough, working on ad tech, marketing tech, and worked on leading teams in predictive models in the insurance industry. Just a quick show of hands, how many people have used Instacart in the last week? Pretty good.
We need to fix that.
Next we have Jim Roskind. He's one of the few distinguished engineers at Amazon. He's a computer science legend. Built one of the first Python profilers, working on, I was on the C++ ANSI working group, and most recently developed the Quick protocol, which 90% of Google's traffic to Chrome is served using this protocol, which is going to replace TCP. Quick show of hands, how many people use Amazon in the last week? Okay. AI is touching all of our lives. Next
how many Amazon Prime members? Amazon Prime?
This is your demographic. Next, we have Monica Rogati. She's equity partner at the Data Collective and a data science advisor to many startups and larger companies here. She was previously VP of data science at Jawbone and a key player on the LinkedIn data science team. She has a CS PhD from Carnegie Mellon. Quick question there, too. How many people use LinkedIn in the last hour?
Wow.
Pretty good, pretty good. Okay, and lastly, I have Bob Phillips. He's the Director of Marketplace Optimization at Uber. He's formerly a professor from the Columbia Business School and the founder of Nomis Solutions that makes price optimization solutions for the banking industry. Quick question there, Uber in the last week. Nice, Uber here to this conference. All right. Okay, I'll start off with some short answers. We can go down the panel. Start with you, Jeremy. This is, what is the biggest challenge in using AI to optimize marketplaces?
So I think probably the biggest challenge is framing the problems. There are a lot of pretty complicated, interdependent problems across the different sides of the marketplace. And it's not obvious. It's not a simple predictive modeling problem or image classification problem. So figuring out really what are the objectives, how do you appropriately frame it, how do you translate that into the appropriate algorithm is still a very difficult challenge.
All right. Jim?
So I guess maybe my focus is always on efficiency and reducing hardware. So I'd say it's interesting to realize how much compute power it takes to do this sort of thing. AI, or machine learning has come about with I shouldn't cause feedback, the confluence of GPU technology and great performance algorithms and big data, all these, and finally Moore's law helps in the background. All these things help, but even with that, there's always the question of how much larger you can make the model and still make it survive. So I'd say the size of the model is very critical.
Monica?
One of the challenges that I've seen is around finding the objective function and figuring out what are you trying to optimize for. And that's crucial, especially when you have 3 players in the marketplace and you're trying to optimize for different either specified preferences or even implicit preferences or behaviors. So finding the objective function and deciding what you're trying to optimize for is actually very difficult and crucial.
I would add to that the same holds for Uber. We have both riders and drivers that we need to keep happy, as well as, someday at least, profitability for Uber. In addition, we have a very complex spatio-temporal network that we have to keep track of. So looking at the optimization function across the city, we can do a great job at the end of the Beyonce concert to have exactly the right number of Ubers, but if we starve the rest of the city, maybe we haven't done so well after all.
No, that's great. Maybe you can start here, Bob. Like, what kind of solutions are you coming back to time and time again that's like kind of the favorite in your toolkit?
Excel.
Excel?
No, actually,
Excel is great.
Definitely.
so we're extremely promiscuous in our use of the different solutions. Because of the optimization nature of many of the problems, we find ourselves using a lot of the techniques from management science and operations research. We use a huge number of big data, machine learning derived types of algorithms as well. We're very statistically and experimentation driven, so we put a lot of emphasis. We have like the world's greatest laboratory, 400 and some cities that we can run experiments. We're continually running experiments, and understanding the outcome of those experiments is critical to us.
I'm going to go low tech on this one. I think it's really important to put in 1 hour of manual effort in whatever you're trying to do and automate, whatever you're trying to apply machine learning to, because that's going to give you particular insight in how to maybe pre-process the data, what are common patterns that you're seeing, how to use, what algorithms to use, and so on. So just put that 1 hour of manual effort in, and it's going to pay off in a lot more.
And I'd almost go a lot with the first answer. It's a theme that I stressed through years at Google as well. It's A/B testing, aggressive A/B testing to verify the user is served. At Amazon, everything is extremely customer-centric. If you use Prime, there's a reason. It's because we try very hard to service you. So constantly testing, measuring, seeing we have value to the customer. That's the critical resource and the critical thing to keep measuring and not just believe other metrics. The comment about get the metrics right. The real metric is the user satisfaction.
So in terms of specific algorithms that we come back to, similarly on the operations research side, mixed integer programming is still kind of bread and butter in a lot of cases. Similarly, I love gradient boosting decision trees. It's a very safe choice and sometimes very difficult to beat.
No, that makes sense.
So the two pieces, one were mixed integer programming, and the other one was gradient boosting decision trees. You're welcome. I'll try to talk into the mic better.
Did you hear all the other answers, or that was the only one you cared about?
That's great. So let me do a little bit deeper dive into some of the problems that you guys are working on right now. Bob, I'll start with you again. What kind of, you already talked a little bit about the spatiotemporal problems. So what kind of problems, what are the key problems that Uber is trying to solve, and what kind of techniques and people are you using to solve them?
So the key problems that fall in my domain is everything around pricing, what we call matching, which is both dispatch and pool matching. How do we match pool customers with each other and with drivers? And then we also call driver positioning. And a lot of the issues that we face come from the fact that both on the rider and the driver side, since our drivers are our customers, not our employees, we can't tell them what to do. So we have a lot of machine learning around, if we put this set of signals out in the marketplace, how will drivers as a group respond? How will different types of drivers respond? The kind of people we're looking for are the people who can really understand the problem. I think one of the things that sometimes gets lost in discussions of AI or machine learning is the importance of causality. So as Uber, we're really interested in causality. Not that drivers tend to go here for some reason, but did they go there because we sent them a signal, because we told them something, or we offered them a particular incentive?
That's great. Monica, can you touch on something from maybe your recent experience or even back in your LinkedIn experience or labor markets?
Sure. So yeah, my experience is around labor markets and building algorithms to match people to jobs and jobs to people. And that's a very interesting one because people, again, behave sometimes irrationally, and you have to get to the bottom of all the variables involved. So there it's an interesting problem of using machine learning to figure out what are people going to apply to, what would make them happy, what would be a good job. How do you figure out where geographically do you show a job targeted to them? So it's a very, very interesting problem. And there's all kinds of surprising things. So for example, people get really, really offended if you suggest a job that is below or equal to their seniority level. They take it super, super personally, right? So it's not, so when you build your objective function or when you look at your factors, you have to take that into account. You have to take into account the fact that, hey, if I show them a job that's too senior, they're a little bit flattered. So even if they're not applying to it, it's a good experience for them. It's a positive one. But if you show them a job that's too junior, then they're offended, which is a lot worse. So it's not symmetric in that sense. And sometimes in recommender system, you just have to constantly look for extra liquidity in the market. You have to bring in new inventory on both the supply and demand side. And sometimes the best match is not good enough. So sometimes you just have to not even offer a match if it's not good enough. So there's a lot of lessons there around methods and how people perceive the labor market, and there's a lot more work to do too.
Thanks, Monica. Jim, could you talk a little bit about what Amazon is doing and with kind of the techniques and the problems that they're trying to solve in their marketplace optimization?
I'm a little new at Amazon, 6 months, but I've seen the same sorts of problems, I think, in part as I've seen at Google and other places before it. One problem is sometimes people second guess when you give an answer, why you're giving the answer. The easy example is they do a search for shoes made by company X, and then you show them shoes sold by company Y, and they go, this is not fair. This is not fair. And the answer is no. We have experience. The company X versus company Y, they actually end up buying company Y. You probably even, we'll show you some company X, but company Y might be better. This is an issue for Google historically when people question why are they putting this up as a high probability answer? And the answer is time and again, Google used to have to read what you typed and correct you and say, I don't think you really even meant that. And they've learned this over time. So it's a little bit of this almost transparency. There's an issue of people are confused. Why would they ever show me X? When I ask for one fruit, why did they show me another fruit? The answer is you actually sort of want that. And so I'm wary of this government regulations of, you must explain to us why you did it. And it's very difficult to do, especially if you build deep neural nets. Explaining is not the first thing that comes to mind.
Jeremy, could you talk a little about, we talked about it, like the four-sided optimization problem that Instacart faces. Sounds very challenging. Some of the techniques and things that you're doing, the people that you're trying to hire to help you solve those problems.
Yeah, so the four sides of the Instacart marketplace are the obvious ones, the customer on one side and the personal shopper on the other. We also have the retailer, the physical stores that we shop out of, and then the millions of different products, grocery products that our customers can buy. So the market for groceries in the US is about $700 billion. 30% of those dollars spent by customers go back into marketing and trade promotions to try to change your mind about what pasta sauce to try next. They're not terribly efficient or effective. And so a huge part of our business is, well, how do you really make discovery and search and personalization in grocery work well? How can you use data online to create an even better grocery shopping experience than you can in the physical store? And then there's the flip side of our business, which is more similar to what Uber does in terms of how do we actually do the last mile delivery? How do we get you groceries delivered to your doorstep from Whole Foods in as little as an hour? And a part of the challenge there, if you consider Uber's model is more of an auction, you want a ride, it immediately clears with the driver. We're committing to you a grocery delivery that's going to be fulfilled over the coming hours, and that means that we have different role types. We can have somebody who picks the groceries and then delivers them, someone who just picks order after order after order at the store, and some stages them at the store, and then another driver comes, picks up 5 deliveries and does them in a sequence. So we have a lot more control. There's also a lot more options, a lot more flexibility in terms of how we optimize that system. And so thinking about how do we balance supply and demand on one side, and then how do we optimize fulfillment so that people get their deliveries on time and we spend as little time as possible. In terms of people that we have, we hire a variety of different folks. Increasingly what we're doing is we're actually taking some of our engineers and trying to turn them into machine learning engineers, giving them the education, the opportunities, the mentorship, the coaching, And then we're increasingly hiring experts externally, people with really deep subject matter expertise to be those mentors. So we're finding that model to work well.
Nice, nice. Actually, we touched on this, something I wanted to explore on testing. And Jeremy, I wanted to talk about this. Like, you know, we talked about A/B testing, which is great for, you know, the web page optimization world and this sort of stuff. But like you mentioned, there's some key challenges of doing A/B testing in a marketplace where there's physical people involved. Can you talk a little bit about the issues you face there?
Yeah, so the real problem on the logistics side for us is how do you define groups A and B such that they are truly independent? If you've got a new algorithm for optimizing how you're routing shoppers in space and time, and you deploy that for 20% of your shoppers, that could very well rob the other 80% of the right opportunities to be efficient. And so you're not going to get a clean A/B test result. There's no division. You can't divide customers. You can't divide trips. You can't divide shoppers. So ultimately, A/B testing just isn't possible. What that means is you can either just release something and see if the time series metrics improve. That's pretty difficult. You can try to flicker things off and on, but that's pretty challenging if the system takes hours to clear jobs. You can't flicker fast enough. And so maybe you can really flicker effectively daily, but you're going to wait for a long time if there's a lot of volatility. And so increasingly, you know, we're taking our batching system, which creates long-term plans, and using that as a simulation engine. So we're actually simulating what our shoppers would do under different circumstances, and, you know, increasingly trying to improve the accuracy of that simulation so that we can do virtual A/B testing.
Bob, maybe you can add some color to that. What does Uber do to kind of test all their new algorithms and techniques?
Well, we do a lot of classic A/B testing, but we're very aware of the same pitfalls that you just mentioned. I mean, so if in a city we're doing something, we find that, you know, we try to cohort our drivers into cohort 1 and cohort 2, or riders into cohort 1 and cohort 2 and do a test. We have to be very careful because the rides that one group gets may get extra rides, but many of those rides will be taken from the other group. And we can't count that as being necessarily being accretive. We also have the issue that while we have all these cities, the great thing for testing is that's a tremendous advantage because it gives us a lot of test beds, but it's also problematic. If consumers respond this way in San Francisco, does it mean they're going to respond this way in Moscow or in Jakarta, where it's a very different competitive situation? So we're spending a lot of time, and it's one area we're really looking to beef up in how can we do these principal tests. There's a lot of emphasis in statistics now about matching algorithms to kind of help improve and boost the results of A/B and switchback type tests, and we're beginning to employ some of those so we get a really clear view of what the actual results are.
And do you guys use anything like flickering or simulation engines and stuff like that?
Yes, we do.
Sounds good. Monica, Jim, did you want to add any color around like your guys' experiences on testing your machine learning algorithms in the field, in the wild?
I think it becomes a little bit more difficult when you have a lot of network effects, and when one person can influence the network, their own network. So for a lot of times, a lot of the social media companies did some testing, for example, in New Zealand, where it's English-speaking, it's culturally relatively similar, and you have this contained graph that's separated from the main United States graph, so you can hit a smaller number of people while still preserving the network effects. Because if you sample a graph, you weaken the network effects, so you can't sample properly, but finding a particular region where they're all connected, then that preserves the properties of the main graph. So that's an idea that people have discovered.
Nice.
I'll just say I'm immensely sympathetic to the problem you're facing. We're very fortunate at Amazon to have large numbers. This is a giant advantage. Historically at Google, advancing Chrome, we would decide whether we wanted to have a cohort that we would maintain over a period of time, or it was usually the optimal thing was to have A/B testing done same day, same time, across 10, 100 million users, which gets you real data pretty darn fast. We'll use the word darn. So yeah, I'm sadly sympathetic when you only have 20 drivers or 100 drivers in an area and you're trying to get data. It's got to be murder. So but the answer is get big data. Think about clever ways that for us on the web and historically in Amazon, big data is the answer over time.
Well, we do our tests. We usually have thousands of drivers and 10,000.
I apologize if I was disrespectful.
It's okay.
They're very small drivers, though, right?
You may be thinking of our competition, but I would add, in simulation, we do use simulation, so it's sort of like the initial gateway. So the thinking is if something doesn't work in a simulated environment, it's almost certainly not going to work in the real world. And if it does work in a simulated environment, it's about 50-50 whether or not it'll work in the real world. So we never put anything out there on the basis of simulation. Simulation kills some ideas, but it's never used as the final arbiter. We really have to see it working in a real A/B test.
Yeah, I'd agree with that. And the other half of the time, it means something's broken in your simulation, right? That needs to be fixed, which is super insightful.
The test bed itself has a bug.
And that also, by the way, jumping back to Chrome, the in-laboratory tests were worthless compared to actually real-world tests with, as I say, millions of users on real PCs with real concurrent traffic, real time of day, going to sites they really cared about. Anything else is just almost a waste, I felt.
And I think a lot of that comes back to the human element, which I think you mentioned. For example, in pool, we found things that work well in simulation, but then we find psychologically people don't like certain pool trips if they psychologically feel it's taking them in the wrong direction, even though from an algorithmic point of view, it's taking them in absolutely the right direction. So just like people believe in Palo Alto that the peninsula runs north and south, runs east and west, people have this psychological idea that, oh, I'm going way in the wrong direction here to pick up this second pool passage, or when you look at it, it's maybe 5-minute deviation on a 45-minute trip.
That makes a lot of sense. That's really cool. Another thing that came up in some of the conversations we had earlier was around kind of the role of human creativity versus this modern machine learning, like deep learning, how it's like there's this fantasy where it's like, oh, it does all the feature engineering, does all the algorithm design. It's just like, you don't need data scientists anymore. We're all going to be out of a job, like it's magic. Monica, you had some like good thoughts and specific insights around that.
Sure, yeah. I mean, deep learning is math, not magic, right? But in some cases, it is the technology is sufficiently advanced that it is indistinguishable from magic. However, there's a lot of places where it hasn't actually necessarily worked because the level of abstraction that you need to think of is a little bit higher than where the technology is currently, right? So to give you an example, you could use deep learning to look at a LinkedIn profile and figure out what skills and experience that person has that maybe they didn't put there, but they're implied from their job title and from the company that they're at, or maybe some other skills that co-occur with what they did put in the profile. What you can't necessarily do, not now, is to say something like, hey, looking at our global LinkedIn population, we noticed this trend of people moving from Detroit to Austin, people in the auto industry maybe. And we see this trend at the global level. Therefore, when we show jobs to people in Detroit, instead of saying, only show me jobs in Detroit, have a business rule there, say, hey, let's add in the transition probability or the move probability that somebody's going to actually go from one place to another. So build that into the model, build that into whatever model you're using. And so that's a feature, a signal that a person could put in, a data scientist could put in. But right now we don't have the technology to make that, where the data is not even presented in a way that's conducive to deep learning, even understanding that that's a thing, right? So we're still, maybe we'll get there, right? But they said the same thing about software engineers back in the Rational Rows days when we just like point and move block, most of you are too young for that, but moving things around, right? To do software engineering programming, and that hasn't, we still have software engineers now, so I think our jobs are pretty safe.
Jim, you had some thoughts around that as well? Or?
Yeah, that was a humorous dialogue. He said, what about creativity? And I said, what about creativity? I think time and again we see the evolution of technology, and people keep thinking that it's going to displace all the creativity in the world. And yet I see the creativity piling upon the great advances in technology. I think about how can you be creative? The chip layout is all done automatically. And that allows us to think about a bigger project and go farther. So time and again, this fear that will be displaced and creativity is lost, the answer is no. Every single advance we've ever seen, we've seen advances in creativity building upon that, and there's no reason to think that's about to change.
Jeremy, Bob, you guys have any thoughts?
No, I think it's been said pretty well. I'm sort of hoping for that day. I spent a lot of time recruiting, and if I just had that box that could replace all of the creativity, I'd spend a lot less time recruiting. But no, I mean, I think as we've seen the capabilities advance, we've just seen the requirement for really understanding how to use these tools creatively advance right along with it.
Nice.
Yeah, I think it comes back to things we were talking about earlier, how hard it is to select the right objective, to frame the problem, how hard it is to go from an algorithm that is optimizing for an objective to one that actually changes human behavior, and all of the shock absorbers you need in a real system to deal with the implications of the lossiness of the algorithms and the impact that they have on the real world. So I see a tremendous amount of opportunity for creativity.
Great. I'll do one last little rapid fire round before we can move on to the audience questions. And by the way, I didn't mention it before, but if there's people already doing it, yeah, please post your questions in the app, upvote them, and we'll just take them off the top when it time's for audience questions. But I myself had some questions, and so since I'm up here, I get to ask them first. But these are simple, one word, one sentence answers. Just wanted to get from you guys. So first one is technology cycles are often, kind of described as like 15 years long, like mobile, PCs, internet, these kind of things. What year of the cycle do we think we're in for AI? Jeremy, I'll start with you.
We're in like the third cycle, but of this cycle, probably I would say the fifth year.
I think it's a mistake to think the cycle stays at 15 years instead of like dog years, and now we're going to have machine learning years, which are even faster. So I think, as I say, it's like hyper-exponential confluence of multiple technologies moving us along at a wonderful rate. So I refuse to try and think of it as countable.
So in 2011, the precursor to TensorFlow was put into place, and then in 2012, there's a lot of advances around the ImageNet competition being won by deep learning like algorithms. So I would put that, I would make that the start. So then that brings me to year 5. So I guess, I don't know about the 15 years, but I would say year 5.
Got it.
Yeah, I guess I'm old enough to remember the beginning of the cycle in the 90s with inference engines and fuzzy logic and everything else. I think I would say year 3 to year 5 and something where we really are going to see sort of an exponential speed up of use of these capabilities.
Got it. Next one was in the particular context that you're working in your company, like how much improvement do you think is left in the marketplace optimization problem? Like 10%, 100%, 1,000%? Where are you in solving that problem? I'll start with you, Bob.
Yeah, we attempt to measure all of this, and short of autonomous vehicles, but with human drivers, we probably are getting about 50% of where we are.
Got it.
Could be.
For labor markets, we are very inefficient right now. We have people not moving around, people being having a job for a long time, people not necessarily working at the job that they want that makes the most of their skills, or people not necessarily learning maybe a delta of a skill that puts you into your next job and opens up a bunch of new opportunities. So I would say more towards the 1,000% side.
So keeping my role as in sarcasm, everything that needs to be invented already has been invented, so we're about done. But the real answer is I think we're barely scratching the surface. We see supervised learning. We see the growth of reinforcement learning. There's questions with search of localization. There's questions finally of how do I put a personalized search upon that. I mean, there's just tons of stuff that are going to change the world dramatically. And I don't even know what the next giant company or thrust will be that will switch us around in a way that 20 years ago we would never have realized that this Netscape thing was going to catch on. So.
And sorry, just to say something on top of that, people are asking me, where is data science going to be in 5 years? And I just say, look, 7 years ago, this whole thing didn't even exist. I have no idea, right? I mean, it's hard to predict where things are going to be if things didn't even exist 7 years ago.
So short of 3D printing groceries in your home, which we may or may not be working on.
They're not that tasty.
Yeah, well, we're working on that. We're still bound by the speed of light. So, we're not going to move the groceries any faster than that. So I think, practically speaking, we can get 100% performance gains without radically new technology. But I think that in some sense, it's the wrong way to look at it. There is 1,000 or 10,000% of investment left that will be really high ROI.
Got it. That's great. So let me go ahead and go to the questions right now. I'll just read them off of this rather than the thing. But I'll just throw it out there and we'll let you, whoever wants to start answering. Okay. Number one, drivers are our customers, not our employees. Sorry, that's still a tough position to reconcile. They're probably the most surveilled non-government employees ever. I'm guessing this is for you, Bob.
Could you put that in the form of a question?
All right, next one. Whoever answered that, do they want to ask it again? All right, we'll move on. So next one is, what new markets do you believe AI will enable in the next decade? Yeah, what new markets do you believe AI will enable in the next decade?
Well, so one of the things I'm really excited about is AR and VR. And the intersection of AI with those incredibly immersive experiences. We talk about technologies to travel, but will we need to? And what will it look like when that really is high quality and widely distributed?
Any other visionary thoughts?
Probably if we really were good visionaries, we would be earning our money elsewhere. But yeah, you are
being on our yachts in
are.
Aruba. Is that what you're saying? Yeah.
Yeah. So it's really I've had the joy of living through many of these trends, and it's just murder to see the next great thing. The one thing I will say is machine learning. I feel like I'm in Alaska during the gold rush. I can't believe the quality of the voice recognition on the Android. I can't believe the quality of the image recognition. And then you jump in and you keep turning over rocks and there's nothing. And then a guy walks up behind you and goes, oh, this one, a giant piece of gold. So I don't know what it is, but it's growing at this incredible rate. And I think the tooling is going to be the source. And if we could predict, yeah, we could be venture capitalists in the audience. But
They're in the other room, I think.
Okay.
We're in the wrong room for that. Go to the next one. Amazon. Why is it that after I buy a product on Amazon, I keep getting ads for the same product? Why send me ads for something that I just bought? Jim, 6 months there. Please solve this problem.
And 18 people have thumbed that up. So
See, I also, if you look back at the history, I also worked at Netscape and then if you merged with AOL, and they used to tell me about a trifecta. A trifecta was when you got there were ads on the right side, 3 different ads, and if they all rolled to the same exact ad, so you had 3 copies of the same ad, that was a trifecta.
it's like a slot machine.
Yeah, and the point was it was too hard to figure out how to get it right. So there are certainly problems. One, if you would shop at Amazon more often, we wouldn't be confused about whether you needed more. But I don't think that. I don't know exactly how the engine works. It tries to understand, and certainly you're going to understand that it can make mistakes, and you can show up the second time at a store, and a person will say, "Oh, didn't you want? They have these nice. Oh, I bought a pair. Oh, but these are really nice." And so it happens. So I think personalization is a little bit confusing, but at times it's the real goal. And I've mentioned this before. Amazon is customer-centric, so time and again you'll see us trying as hard as we can to improve your experience, reduce shopping friction, and make your life better. And the bad news is we try and we do exploration. They talked about this. We'll make little mistakes, and we try and get better. We constantly try and get better.
I might, just from an ad tech background, I don't know if this is at all true, but if those ads are being served by third parties, they may have seen you browsing, and that may have been cookied and then triggered to generate an ad that appears after you actually bought the product on Amazon anyways. So it's an example of like your data kind of being siloed in a broader ecosystem and you seeing inconsistencies because of that siloing.
It's still a one-line code fix. I think the question hasn't been answered.
Are you looking for a job to write that one line? Is that it? See me afterwards. We'll see what we can do for that one line.
Nice, nice. Let's do a few more. I think we have a few more minutes. So regarding objective function design, at what point do you factor ethics in? Even if the objective is obvious, do you need to consider other implications? We actually talked a little bit about this.
We talked about that, and we talked about the trade-offs depending on your training. If your training data is biased, it's very likely that your results are going to be biased in the same fashion, and then that's kind of like this compounding spiral where you end up with worse and worse results, and depending on how often you iterate on your model, you can end up very quickly in a corner. So very often you have to consider the result that you're getting and what is the trade-off between accuracy and bias. And that's only one portion of the ethics question. The question is, which is, to what extent are we comfortable having so much bias in the system that when it's trained on biased data, you see the same bias coming out in the algorithm. So that's one ethics question, and the other one is around what kind of data is okay to use, right? And so that's a more complex question because even if by law you can't use certain types of data, it turns out that a bunch of the things you do are predicting the type of data that you're not allowed to use, right? So it's kind of toothless in that sense. So there's two sides of the ethics coin that are really interesting to think about and that people are taking seriously and working on.
Mm-hmm. Jeremy, you had some insights from the insurance industry too, right? Like there's like regulated.
Yeah, I think in that industry, you will have regulators that will just test the application of the models to see whether or not they have effects that are illegal. And so I think that can be replicated in lots of places, and it comes back to A/B testing. And how accurately can you capture the true long-term intent in your A/B tests? And that's probably the most difficult thing is not optimizing for what you see in the one-day test because you've got scale with data, but seeing what happens to the customers 7 days, 30 days, 100 days out.
Got it. We'll do one more, I think. Okay. So more technical one. Okay, what approaches do you take to address user behavior evolving over time or in feedback with your interventions and or decisions? I'll ask you first, Bob.
Sure. I mean, for us, it's very much a question of we want our drivers to come back. Driver acquisition is a very expensive proposition for us, as is rider acquisition. So we have to measure over the long term. And any treatment that we give, we can't say, oh, this was just great, it worked really well today, we got this great result for the drivers. But if our drivers start drifting away because of that, in 2 months, 3 months from now, we don't have the driver base or the rider base, we're in trouble. So we have to watch this out several months if we feel there's some sort of implication for behavior. And again, one of the things we find is that some of the things we try to tell drivers, if we think there's a 90% chance there's going to be a lot of rides in an area, we say, in this area we think there's a lot of rides. But that means 1 time in 10 on the average, the driver's going to go there and say, oh my God, there's not many rides here at all. Uber screwed me over again. And then they go and post, oh, Uber just driving us around the city for nothing. Even if the last 8 times they had a great experience. So we're super conscious of this sort of thing. And maybe we have to make sure it's 99 times out of 100 when by the time they get there, there's still going to be lots of rides around. So
you have treatment cohorts that you're tracking over time?
Oh, absolutely. Yeah. Absolutely.
Yeah. Anybody else want to answer a little bit?
Yeah, so I mean, I think a lot of times A/B testing is one way to deal with that, the cohorts and looking at behavior evolving. In the recommender systems, a lot of times you have to account for presentation bias and make sure that the order that you've shown things in and take into account what the user has seen and build that back into the algorithm. And so those are two methods that you can try to alleviate that problem.
Certainly, I already mentioned, and I'll keep repeating, customer obsession and focus on customer. There's another one that's very, very important. There are these leadership principles that they stress, is building trust. And the trust has long-term effects, and we constantly look for retention of customers. So we worry about the trust involved in giving proper and honest reviews and not truncating them. The trust involved in delivering a product when we say we're going to deliver the product, and sadly saying we can't when we can't. So we build these things in elements of trust, and we work very hard to measure the long-term retention and the acquisition of new customers. These are very important.
So I'll answer this very tactically. A lot of classical machine learning problems, machine learning algorithms will require hand-coded features. Those will tend to be aggregates. Those will age slowly with customer behavior. Something like matrix factorization and recommendation systems will generate a fixed encoding for the user. It will age slowly as new data comes in. So I think one of the exciting things about deep learning is being able to model full sequences and being able to really understand the user's trajectory and predict that in real time. And I think that can actually make models ultimately much better and more interesting for users.
Got it. Well, I think we're out of time. Just wanted to thank the panel for a great discussion.